there are two ways to do this question. The first one is to figure out the general expression for the nth term and then compute this out. And the method I'll use can be used for other questions as well. That if you replace n with n minus 1, then the first piece remains the same. The last term here would be minus 1 to the power of n x sub n minus 1, and then this becomes n minus square plus 2 times n minus 1. Now here, the pieces from x1 to x sub n minus 1 is the sum that I have here. And I can replace that here, and that means I will get an explicit expression for the nth term. Because all I've done is replace n with n minus 1, and then replacing that sum. And I can expand that. This is n squared minus 2n plus 1 plus 2n minus 2. And this is our nth term here. And you'll see these two terms would drop out. And here I would be left with minus 2n minus 1, which if I move to the other side, I'll have an explicit expression for the nth term. So from this, we can now figure out x49, replacing n with 49. So this would be 50. Actually, I should leave it here, and I'm simply replacing n with 49. And this would be 49 times 2 plus 1, which is 99, and this is 1, so x49 is 99. And similarly, we can replace x with 50, and then this would become 101. This piece is minus 1, which means x, the 50th term, is minus 101. We're asked for the sum of these two, and that becomes minus 2, which is choice D. So that's one way to do it. I think that's the most efficient, at least as far as I know. The other one is, if you're not able to see that or able to do it, you can try to look for a pattern for these terms, starting with the first term. So if you replace n with 1, the sum up to first term x1 would be 1 squared plus 2 times 1. This would be 3. So that's your first term. Then if you do n equal to 2, we'll get that sum, or I should say x1 minus x2. And I'll rewrite this as n times n plus 2. So now n is 2. So this becomes 2 times 4, 8. And from this, I can figure out x2 is x1 minus 8. So minus 5. So you keep doing this until you see a pattern. x3, and then this would be 3 times 5 is 15. This piece is 8, so x3 is 7. So if we write out our terms, 3 minus 5, 7, and then it would be x minus x2 plus x3 minus x4, and then 4 times 6 is 24. That piece is 8, and then x3 is 7, so that's 15. x4 is minus 9. So you'll start to see a pattern. These are off by 2, but the signs flip. So it will be 11 minus 13, so on and so forth. That means the 49th term, if you just look at the magnitude, which we know this is first, second, third, fifth, will be positive, and it would be 3 plus 49 minus 1 times the common difference, 2. So that's 48 times 2, 96, 99. And then we know x 50th, which would be a negative term, and then 2 more in magnitude, so it would be minus 101. So we get what we had earlier, and the sum again is minus 2. So either of these two approaches, there are probably other methods too. These two are what I can think of right now. So the answer is D.